Welcome back, everybody. In this video, we're going to look at a couple more examples of graph transformations involving reflections and shifts. And I already went ahead and graphed the original equations, which are in black. In the first example, we have f of x is equal to x squared minus 4. We have f of x is equal to the absolute value of x plus 1. And then in the last example, we have f of x is equal to x minus 1 squared. So we're basically trying to figure out how to graph the equations written in green. Now, if you're not really familiar with how the graph is going to look like, we can always construct a table of values just to make sure that we have the correct graph. And then from there, we can interpret how the graph has changed. So let's begin with the first example. We have g of x is equal to negative x squared plus 4. Now you can tell there's already going to be a reflection across the x-axis just because the negative sign is out here. So if we were to construct a table of values, we can go ahead and just do that. We'll make sure this is showing on the board. Let me try to move this. See if we can move it here, just to make some more space. We have x and g of x. So let's go ahead and start with, well, we can always start with -1 and then work our way up to 1, so -1, 0, and 1. But the more points you add, the more precise the graph is going to be. So if we take -2 and -1 and work our way up all the way to 2, we're going to get a more precise graph. So all we got to do is plug in those values in for x, and then we're going to generate values for y, or g of x in this case. So if we take -2 for negative x squared, we're going to get -2 squared plus 4. Well, -2 squared is just going to give us 4. And then -4 plus 4 is just going to give us 0. We have -1 squared plus 4. -1 squared is just 1. And then -1 plus 4 is going to give us 3. Now we have 0. 0 for x squared is just going to give us 0. And then 0 plus 4 is just 4. Now we have 1. Plugging in 1, we're going to get -1 squared plus 4 is also going to give us 3. And then plugging in 2, we're going to get -2 squared plus 4. 2 squared is 4, and then negative on the outside is going to become -4 plus 4, which is just 0. Now we can go ahead and plot those points. Our first point is -2 and 0, so that's just here. We have -1 and 3, so 1 unit to the left, and then 3 units up. So that's somewhere here. We have 0 and 4, so we just move up 4 units. So that's here. We have 1 and 3, 1 unit to the right, and then 3 units up. And then 2 and 0, which is just here. Now if we go ahead and plot those points, our graph is going to look like this. Now you can tell what happened after this transformation has taken place. Notice that we have a reflection across the x-axis and that the graph has shifted 4 units up. Well, in this case, it shifted 8 units if we compare it to the original equation. So that's our first graph. For our second graph, we have an absolute value of x plus 1. So it's just the graph of an absolute value that started at the origin and has shifted 1 unit upward. So we can go ahead, construct our table of values again. We have x and g of x. We can also start with -2 just to get a more precise graph, and then work our way up to 2. Now plugging in -2 for the absolute value, we're going to get -2 minus 1. Whenever you have a negative value in the absolute value, that's just going to turn to positive. So that's basically saying -2 minus 1 is going to give us -3. Now we have -1. So the absolute value of -1 minus 1, that looks a little bit confusing. I don't know if that helped, but so the absolute value of -1 is just 1, and then we have the negative outside, so -1 minus 1 is going to give us -2. Now if we plug in 0, negative absolute value of 0 minus 1, well that's just going to be 0, so 0 minus 1 is going to give us -1. And you can see where those points are going to. Now we have the absolute value of 1 minus 1, well that's just -1 minus 1, which is just -2. Then we have 2. So the negative of the absolute value of 2 minus 1, that's just -2 minus 1 is just -3. Now since we have all our points, we can go ahead and plot them. So our first point is -2, -3, so that's 2 units to the left and 3 units down. So 1, 2, 1, 2, and 3, so that's somewhere here. Now we have -1 and -2, -1 and -2. And we have 0 and -1, which is just 1 unit down. And we have 1 and -2, just 1 unit to the right, and then 2 units down. And then we have 2 and -3. Just 1, 2, and then 3 places down. 1, 2, and 3. And we can go ahead and plot and connect those dots. And there's our new graph. Notice how the function has shifted, or excuse me, has reflected across the x-axis. For our last problem, let's see if I can move the board a little bit to the left. Okay, that's better. So we have our table of values. We have x and g of x. Now the original function is simply a parabola that's been shifted to the right 1 unit. And we're going to go ahead and see how the new function looks like. So putting in -2, -1, 0, 1, and 2. Remember, you can add as many points as you like, but I like to stick, I usually go from -1 to 1, just to get a rough sketch. But to get a more precise graph, the more points you add, the more precise the graph is going to turn out to be. So -2, and for x, we're going to get -2 minus 1. All this squared. If we go ahead and simplify, well, we have negative times -2, which is just +2. So 2 minus 1 is just 1. And then 1 squared is just 1. Now we have -1. So -1 minus 1 squared. Negative times negative is positive. So that's 1. 1 minus 1 is 0. And then 0 squared is just 0. Now we have 0. -0 minus 1 squared. So negative times 0 is just 0, and then 0 minus 1 is just -1, and then -1 squared is 1. Now we have 1. So minus 1 minus 1 squared. Negative times 1 is going to give us -1. -1 minus 1 is going to give us -2. And then -2 squared is 4. Now we have 2. -2 minus 1 squared. We have -2 minus 1, which is -3. -3 squared is 9. And we can go ahead and plot those points. So -2 and 1. So we're going to go 2 units to the left and then 1 unit up. It's going to give us this point. And we have -1 and 0, which is 1 unit to the left, and then we'll just stay there. We have 0 and 1, which is here. We have 1 and 4. So 1, then 1, 2, 3, 4 units up. 1, 2, 3, 4 units up. We have 2 and 9. Now we don't have to, since our function is restricted to, well, at least, the plane is restricted to 5 units, to 5 increments. We don't really have to include this point, but we know that it's somewhere up here. So roughly, we can say that the graph is going something like this. But what's happening here? Well, at -2 is just 1. So if we add one more value here, a lesser value, let's say -3, we can see how the function is behaving when x is at -3. So So I'm gonna go ahead and erase this since we don't need it. I'll go ahead, put -3 here, and then plug it into the equation. So -3 minus 1 squared negative times -3 is going to give us +3, and then 3 minus 1 is going to give us 2, and then 2 squared is just 4. So this is 4. This is equal to 4. So at -3, our y value is going to be 4. So at 1, 2, 3, our y value is going to be 1, 2, 3, and 4. So it's going to be somewhere here. Now all our points fit on the graph. And if we go ahead and plot and connect those dots, our function is going to look like this. So the function has been reflected across the y-axis, and there's also a horizontal shift towards the left, 1 unit. There are many, many problems that you can do, and the more you do them, well, the better you'll be at it. But you just have to be careful with your math here. As long as your math is correct, then you won't have a problem graphing the equation. And then you can basically tell from the given functions how the graph is gonna behave like. For instance, if there's a reflection or if there's a horizontal or a vertical shift, as long as you stay consistent, and then as long as your math is correct, then you won't really have a problem graphing. So that's it for today. Thanks for watching. Please don't forget to subscribe and like this video. This is going to help the channel grow more. If you have any questions or concerns, please go ahead and leave a comment in the comment section below, and we'll see you next time.